Greetings from Bulgaria. In today's tutorial, we will discuss StaleElementReferenceException. So, what we will learn in the video. First, we are going to discuss in many details what this exception is all about. Then we will see some examples with code when this exception can happen. And of course, we will discuss 5 different ways how we can solve this particular exception in our tests. First, we're going to discuss a simple way how we can reinitialize the elements, and then the exception probably in most cases will be solved. Second, we're going to see how we can use retry logic with whoops, while whoops, for whoops, trying to find the element a few times. Even we're going to abstract the logic in a separate weight utility class that we are going to improve over time. We'll discuss some of the built-in ways in Selenium, like WebDriver weight together with training some of the expected conditions that you probably watched some of our videos on the LambdaTest channel. And lastly, we'll discuss some edge cases when your website is highly dynamic using AJAX requests and refreshing just small parts of the web page, and how we can fight that using small pieces of JavaScript together with WebDriver weight. So, if you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified about the new awesome videos that are published each week on the channel. Also, you can check the awesome LambdaTest blog, where there are many detailed articles about many of the problems. And let's begin. First, what is the StaleElementReferenceException? Before explaining that, let's first discuss some of the common errors that happen during writing of Selenium tests. While we develop new automated tests with Selenium, sometimes we can experience some exceptions. You can check my detailed video about Selenium exceptions on the LambdaTest channel. There are at least 30 of them. So let's mention just a few of them. So first you have element click intercepted exception. This happens when the target element is obscured and cannot be clicked. Similar exception is element not interactable exception, and this happens when the web element is present but in a not interactable state. There are various other exceptions, like no award present exception. You try to work on a word that it's not there yet. Usually this happens when you use switch to a word method, or the popular no such element exception. This is when an attempt is made to access an element that it's not available. Usually it's thrown by find element. Also, there are others like no such frame exception, again switch to frame, no such window exception when you try to switch to a window that it's not there, and so forth. And now, a StaleElementReferenceException is a bit more challenging than the rest of them. This is why we have a separate video about it. So usually it's more challenging to handle because the element is stale. According to dictionary.com, one of the definitions of stale is not fresh. Therefore, the StaleElementReferenceException is thrown because the element has been removed from the DOM or is no longer attached to the page document. Possible causes for a StaleElementReferenceException are that the element has been deleted entirely, or the element is no longer attached with the DOM on web page. Of course, Selenium supplies various approaches to deal with the StaleElementReferenceException, and we can use some of the practice, reinitializing the web element, using whoops together with try catch blocks, using expected conditions, and probably some JavaScript to wait for AJAX. Before moving to the demo, let's discuss just in short what is the difference between StaleElementException and no such element exception. The main difference between the two is that If you use the StaleElementReferenceException, you know that the element is not found in the DOM, but it might appear again if you navigate to a different page. On the other hand, if you use no such element exception, you know that the element is not found in the DOM, and this element will never appear again. There is a big difference. You would encounter a StaleElementReferenceException when the Selenium test code refers to an element that is no longer available, not attached or removed in the DOM. And it's a reference that a specific element is stale, not fresh, and prevents the test script from performing an action. So let's see an example, right? Let's see an example. We will use the LambdaTest Selenium Playground. It's an awesome resource that you can play with to test your Selenium knowledge. When you open the main page of the Selenium Playground, our test will click on this table data search. Then this table will be displayed, and we can find this filter here where we can type the in progress, and as you can see, all the results are filtered, right? Then we're going to hit the back button here. We're going to click again, but we're not going to search initially again for the filter, but we are going to reuse the instance of the element, and we're going to search for another status, completed. And at this point, as you will notice, and in short, I'm going to present you the demo, you will find out that here we will receive the StaleElementReferenceException. How we are going to find the elements? The navigation is clear. If we inspect here the DOM, we can find this link, the table data search, using link text. So we are going to use the table data search link text to find this anchor. Then we are going to click it. After that, we need to search for this input here. And if you notice, we have an ID for it. It's called task/table/filter. So we're going to find this input by ID. Then we're going to use the sendKeys method to type the filter. I'm going to show you how we click the back button, and that's it. You can download the full source code. You are going to find the GitHub repo link in the description below. Also, you will find many different resources out there, so check it out. For each video, as you know, we have a separate GitHub repo. You can download it and play with it. So it's a standard JUnit project. We use Maven. If you are not familiar with JUnit, I suggest you to check my JUnit series on the LambdaTest channel. They are quite informative. And also there is a whole series about Selenium 4 that you can watch for. Just in short, in the Maven POM XML, we need to install some dependencies. So I installed all of the required JUnit dependencies here, and the ones for Selenium. So I installed Selenium Java and WebDriver Manager that we use it to download the proper driver. Then under tests, I created two files. One of them will execute our tests in the LambdaTest cloud, and the other is just a regular test class that holds an instance of a Firefox driver that I'm going to use, WebDriver wait. As you know, we use the before all JUnit attribute, so basically this method will be executed before all of the tests. And here at this point, through WebDriver Manager, we are downloading the correct version of the Firefox driver based on the version of the Firefox browser that's installed on our machine. Then, before each test, we are starting the browser, the Firefox browser. We are maximizing the window, and then we initialize the WebDriver wait. That's it. And now, let's discuss the same the same demo test that I explained. So first we navigate to the playground, Selenium Playground. Then, as I said, we find the table data search link by the link text, which is table data search. We click on it. Then we find the input where we need to type the filter. And as we discussed, we find it by its ID, task/table/filter. And then, as you know, using the sendKeys method, we type the right filter. In order to navigate back to the previous page, you need to click the back button. We do that using, from the navigate method, we have a method called back, which simulates going back. Then, as you can see, we are not initializing again the both elements, but we click it and then we again typing the other filter, completed. And if we execute the tests, if we run it, just we wait a bit the test to be compiled, and then the browser shows up. We click on the link, it's loading, it's clicking, it's typing, going back, and it failed. It's happening too fast, but if you scroll down to the bottom, you'll see that we received StaleElementReferenceException. And basically, as you can see here, this link, even here, it failed with this exception. But again, the same, even if this was okay, it was going to fail here because the element is not attached to the DOM. So the first way to handle this is to reinitialize the web element to handle the exception. So in some instances, the element is temporarily not reachable through the DOM, so we can try to access the element multiple times in a loop, but in a minute we're going to see how to do that. The first way to fix it is to reinitialize the element. So until here, everything stays the same, right? So we navigate to the web page again, we find the link, we click it, we find the input, we type it, we're going back. Until here, everything is the same. The big difference is here. Instead of just clicking the element, we repeat this code here. We search for the link again, and then we click it. We do the same for the input. If you watch my videos about page object design pattern with JUnit or NUnit, you will find out that I actually suggest every time when we get the element in the page object model, the getters of the elements are always searching for the elements just to overcome this exception. So this is the first way how we can fight the problem. But again, sometimes it might be smarter to have a loop where we are going to try to access the element multiple times until it becomes available. And inside the loop, we implement a try catch block and attempt to search for the element. So how we can do that? Just in short, I'm going to show you actually how our test looks like. Again, we navigate through the page to the Selenium playground. We search for the data link, table data search link. We click on it, we type the filter. But the first time when we search for the input, actually even here it's not required. Maybe we can do that on the back button. But here I initialized a special class called wait. As you can see here, it's under the utilities. This is utility class that accepts our driver, and it provides a few methods, retry methods. That here I specify the how my element should be located by referencing this filter. You can directly paste it like this, it's fine. I just define it as a variable so that I can reuse it and not repeat it many times. So we provide here the by filter and how many times the wait utility class will retry to find the element. So let's see how this works. I created this utility class so that we can reuse all of this looping logic so that we don't repeat it among different test classes. So First, through composition, we reuse the driver. So we have a private variable to the driver, and this is why we need to initialize it through the constructor. And as you can see, we have many retry methods that we will discuss now. The first one is called retry while loop. Again, we accept as a parameter the bilocator and how many times we're going to try to find the element again. We first, since we're going to return the found element, we need to declare an instance of it. It's null at the beginning because, it's null because we haven't found it yet. Then we have a temp variable that we're going to increase every time while we try to find the element. And the final count that we're going to try, for example, 3 times, 5 times, we specify here. In the while loop, we check whether our temp variable reached the threshold, 3 or 5 or whatever we specified in this variable here that we passed as an argument. If we reach the threshold, then we are out of the loop. Inside the loop, we have a try catch block where we catch the StaleElementReferenceException. If occurred, we can ignore it, or in this case, I'm just printing it in the stack trace that you can just find out what happened. If we found the element and there are no exception here, we break the loop, and then fine, we return the element. Otherwise, if the exception is caught, we increase the repeat temp variable and we repeat again. It's of course, this is a really important one, that we increase this counter, otherwise there will be an endless loop. And in the end, if, for example, we tried 3 times, 5 times the times that we specified here, and there is no StaleElementReferenceException, but the element is not found, we need to check whether the element is still null. If it's still null, then we're going to throw not found exception. The test will fail because we haven't found the element. Otherwise, we will return the element there. I also created an overload of this method. If we don't want to specify every time how many times we want to repeat, because most of the time you will want, for example, to try 3 times, 5 times. So here in this overload, I just pass the bilocator, and inside I pass here the default of 5. And actually, this is what I used here in the while loop to handle. So yeah, basically we're going to retry to find the element here, and we're going to retry to find the element after we click the back button. As you can see here, I have 2 more overloads. The first overload, actually, as I said, we usually don't want only to catch only the StaleElementReferenceException, but also you want to catch other exceptions. And as we'll discuss later a bit in the tutorial, the native WebDriver wait actually allows you to ignore any exception that you want. So I wanted to put and show you how this works. So I created an overload where we can mention one exception or more. For example, I can ignore just the timeout, or I can ignore also element clicked intercepted exception, or I can add as many exceptions as I want. Just I need to provide their classes. And to do so, actually, this overload of the retry while loop is accepting variable number of parameters. In Java, we do that using this 3-dot syntax. And actually, it's required this to be the last argument. And then we separate them by comma, and the engine will convert this comma separated list of variables, of arguments, to an array. And actually, this will be an array of exception class types. I know that probably for some of you, this might be complex, this generic type. What this means is that we say here, please compiler, this is a class that extends throwable or basically any exception. And we mentioned that this is just a class type that is a type of exception. So you can list any type of exceptions. Most of the code here is the same, but actually the part in the catch block, it's more tricky in order to ignore these exceptions. We have additional variable here called should_throw_exception. By default, it's true, meaning that if we don't ignore the exception and an exception occurs, then this means that we need to fail the test. So by default, it's true. Every time on every loop, we initialize it to true again. And then we try to find the element. If exception occurs, as you can see here, we catch no more the StaleElementReferenceException, but we catch the general exception type. So we for each this array list here with the exceptions that we want to ignore. If the exception that we called is its instance is part of the exceptions list, then we are going to ignore the exception and we're not going to fail the test. So we set this variable should_throw_exception to false, and we increase the counter, the repeat count. And we break the loop the first time we catch that the exception is part of the exceptions that to be ignored. If we iterated through all of the exceptions that needs to be ignored and this exception wasn't part of it, then we are going to throw the exception and we are going to fail the logic. Otherwise, the rest of the code is the same. So yeah, this is how we can ignore certain exceptions. We can go even further. As I said at the beginning, many often in our Selenium tests, we don't want only to repeat just finding the element, but we want, for example, to wait for element to be clickable or execute multiple lines of code that needs to be retried. And this is why actually I created a more general retry method. As you can see, it accepts a lambda expression that we can define multiple lines of Selenium code or any code. By any code, I mean web API calls to set up data or verify data or access the database. It's pretty awesome. And here, as you can see, we can find elements, we can click on them, we can go back, whatever. This is basically anonymous method. Basically, we're providing a method as an argument. The rest, times to retry and the exceptions to ignore are the same. And the way this works is basically instead of, there are two differences. Instead of returning here the element, the method now is void. And also instead of providing the bilocator, now we accept as a parameter supplier. And I name this action. And as I said, this is a special Java class that it's actually a pointer to the memory where this method was defined. And this allows you to pass as a parameter an actual method, and we can execute it. And as you can see, to execute this supplier, we just access the variable and just call its get method, and this will execute the action. The rest of the code is the same. And this is awesome. Again, in many enterprise projects that I'm working on, we use such custom logic for, especially helpful for web APIs and database code. As I said, we can use actually not while loops, but for loops to implement the same. Here is the same test, but instead of retry while loop, I use retry for loop. And here I implemented the same logic, but with for loop. And as you can see, it's a little bit shorter because here directly in the for loop, we initialize the temp repeat variable. We have the same condition, and the increase of the repeat variable is happening here directly in the loop, which makes the code a little bit shorter, and I prefer the for loops, which is awesome. Again, you can do the same refactoring for the retry for loop if you want. And now let's discuss the native way in Selenium WebDriver, we're going to use the expected conditions. There are times when the JavaScript automatically updates the web page between finding an element and performing an action on the element. Respectively, a timing problem can occur and generate a stale element reference exception. Selenium comes with this built-in functionality to solve the problem and overcome the stale element reference exception. We need to implement methods from the expected conditions class here. And the WebDriver wait is the class that helps to develop this explicit dynamic wait statement. If the element is not found, then the timeout exception shows up. I suggest you to check my video about waiting for elements, part of the Selenium 4 tutorials on the LambdaTest channel. It dynamically waits, and checks if the element is refreshed for up to 5 seconds and then wait additional 5 more seconds for the element to be present. But wait, what is this refresh do? I'm sure that most of you haven't used it. You will use the refreshed when you expect DOM manipulation to occur and you want to wait until it's done being manipulated in the DOM. Also, as you can see, I changed it with presence of element located. Basically, this will wait for element to be displayed and then we're going to return it. As you can see, this basically this will return the element itself. It's a generic method. It works in a similar fashion in the way we developed our custom wait utility class. So we wait again first for the filter, then we navigate back. We can do the same for table data link, etc. Also, one last thing, if you need to ignore some of the exceptions, you can do that by using this ignoring method that is part of the WebDriver wait. Here again, similar to what we developed, you can provide different exception classes, and then automatically WebDriver wait will ignore them. Also, you have an overload called ignore all, where you can provide a collection of these classes that you exception classes that you want to be ignored. As you can see, the native way in Selenium WebDriver solved most of the problems, because actually with the WebDriver wait you can add custom timeout period for where timeout exception will be thrown if this timeout has been reached. Also, you can fine-tune the sleeping interval for the checks. For example, it might be by default it's 1 second, but you can decrease it or increase it if you want. So yeah, you can do that. And one last thing, in certain rare cases, for example, in this demo website that I developed for my books, it's a shopping cart. It's using jQuery for making these asynchronous calls. As you can see, this update is happening because we're not refreshing the whole page, the full page, but just part of it, and we have these pinners. In these cases, some of the logic of the WebDriver wait won't work. And in these rare cases where you have this asynchronous JavaScript in Angular, jQuery, or React, you might want to use a small piece of JavaScript to check whether these asynchronous requests have been made and are done. And I use them in combination with WebDriver wait until I define anonymous lambda expression here, executing the script. And in this particular jQuery script, we're checking that the jQuery is on the page. And this piece of code, jQuery active equal 0, would wait for all the jQuery asynchronous AJAX requests to be finished. There are similar JavaScript code for Angular or for React to wait for their engines to finish making the requests. So you can find them online. But you need to be aware that there are some edge cases where the previous techniques won't work, and you will need ways to battle them. So we discussed 5 different ways how you can handle this nasty exception. So yeah, you can reinitialize the elements, you can create retry logic with whoops, you can use the native way using WebDriver waits, or even handle it through some JavaScript code. Thank you for watching the video. If you have any questions, put them in the comments below. I'll be happy to hear your thoughts, or for videos that you want to come next. Also, don't forget to check the LambdaTest blog for many new articles that are published each week. There are many detailed articles about many of the topics, and also don't forget to get your free Selenium certification or JUnit certification on the LambdaTest channel for free. See you soon in the next videos.